Well, so we are about to begin the last round today. We have 8 speakers now. They are very short speeches. We'll have Brian Skripak, Bilal Sukar. Brian Skripak comes from the US. Bilal Sukar comes from Australia, together with Mohammad Kasem from the UK. Javier Chavez from the Professional Certification Office, Spanish one, and also member of La Salle Group. David Morton, Iria Carrera. Tim Broyd is going to have the last session together with Eleno Kiro, which is foreseen for, or we are going to finish today's session at 7:45. If you have any questions, since you have all the speakers will be here tomorrow as well, I would recommend you to ask them tomorrow and to make the most of the time that we have left today for the speeches and the presentation. So with no further delay, we are going to begin with Brian Skripak, who's going to talk about the learning process. What do different concepts in BEAM mean? And he's going to talk about levels of detain, LODs, because past October, the BEAM Forum just passed the last version of the specifications, and he's going to present them. So you have the floor.
Thank you for the introduction, Ignacy. Again, my name is Brian Skripak. I'm a vice president and the digital practice leader at Canon Design in the United States. I'm actually based out of our Pittsburgh, Pennsylvania office. I've also had the opportunity to serve as a past chair for the AIA Technology and Architectural Practice Knowledge Community, which I still serve on, and I'm also an active author and contributor to the BIM Forum LOD specification, which is actually the focus of this presentation today, talking about driving model-based deliverables with the BIM Forum LOD spec. So one of the big questions that we struggled with in the US was this idea of how do we define a BIM? What is a building information modeling element? And how do we have some sort of common dictionary or language so that the architects, engineers, contractors, builders, owners can all actually speak that common language and have an understanding of what information they're receiving as part of the process. So we know that BIM often gets defined as a tool, a process, but what we really want to focus on is the product. What are our documents? What are our deliverables? Knowing that our deliverables are changing from being a paper-based 2D deliverable to actually having a model deliverable. So one of the things we wanted to strive to talk about is how do we understand what those deliverables are? How do we benchmark against it? How do we set expectations in the process moving forward? So these two images really start to embody that idea. The image on the left, early conceptual design BIM. Image on the right, a very detailed trade coordination, actually shop fabrication level building information model. Both of these have very specific use cases at very different times in the model. So for us as an architect, engineer, or builder, we want to be able to say, this is how this is developed. I don't want to over-model information, but I also want to share with my project team and my owner what that information can be used for. Both those models can be used for cost estimating, but they're very different outcomes. One's going to be based on a cost per square foot. The other is going to be based on actual specific components and elements that are to be installed and fabricated about a building. So when we start to look at these and conveying information about what's there, this isn't a problem that we had with CAD. This isn't a problem that we had with those 2D paper-based outputs, because we were reliant on putting everything we knew down on paper. If it wasn't down on paper, it wasn't clarified, it had to be asked. There were no real assumptions. If we needed a dimension, we had a precision or a tolerance accuracy. We put a dimension on the drawing. It was very clear what it was. If you had an 1/8-inch drawing, somebody wasn't going to be able to scale off of it and have any reliability to that information that was in place. That's not the same condition that we have now in a BIM environment. In fact, it's very different. We know that we can start to imply what information's there, but we also know that there's an opportunity to misinterpret information or convey unintended meanings about the geometry and the data that we're starting to put into these models. So very simply, in a 2D representation, we know in the image on the left there's a door. It's in the lower left corner of the room. Great, I know there's a door. I'll have a generic price to it, and I'll find out more information about it later. At the same time, if I passed off a model deliverable and somebody else on the project team looked at it beyond just that simple 2D representation, opened up into 3D, there's a whole wealth of information there that may not yet be accurate about the model that we're developing. Somebody can start to look at that. Now they see that there's a half light in the door. That might actually end up being a narrow light. It might be all glass. It might be a solid panel. It might have a different frame condition. Is that actually the dimensional location and size of that door? When all I really intended to do was show that there was a door in the corner of that room for an early stage planning diagram, there could have been a misinterpretation of a lot more additional information that was not intended to be shared about the project. So one of the ways that people are starting to deal with this is, very unfortunately, to put disclaimers on their drawings. It says some of the information is reliable, but not all of it, so don't rely on any of it. If you use it, it's all at your own risk. Don't call me with any problems. The documents are the final deliverable. That's what we're going to go off of. And that's not a very collaborative way to work. And that was really a big hurdle that the LOD specification wants to start to get by and start to drive a common language so we can start to work with our contracts, our BIM execution plans, and other documents to set expectations that are specified use approaches like we're seeing there. Not everything in the model is to a certain level, but here's the information that is to a certain level of development. Here's what it can be used for. Here's where the dimensional accuracy comes into play. This is what you can trust and rely upon. That's the expectation that we want to get to, not having the blanket comments like use at your own risk. So leading up to multiple conversations that have gone in the industry, in 2011, the BIM Forum was a group that started. The BIM Forum is actually a component of the Association of General Contractors of America, but they also work very closely with the American Institute of Architects to define this LOD, level of development specification that's in place. The outcome of this document is, in fact, that common language. That if we benchmark what our models look like, we know that the people who are going to be using them and interpreting them have a reliability and a place to go to understand what the expectation is and how it can be used. So even though the group started in 2011, it was in 2013 that we first published the initial LOD specification. There's an annual release that typically comes out at the end of the year. We release a public version for draft at the Spring BIM Forum and then the Fall BIM Forum, and by the end of the year we actually have the public one. So the current version is 2015, which you're seeing over on the right. There's a link at the end of the presentation where you can go to download that. It's a free document. It's a free reference manual, so anybody is able to take that information on and use it. The big component of the LOD specification is really this first line. It's a reference manual. It's not a standard. It's not a requirement. It's a reference manual. It's something to be utilized across multiple documents. And the focus of it is to specify and articulate with a high degree of clarity the content and reliability of the building information model and the elements within it across the design and construction process. The idea of LOD is, again, we've talked about not being a set of requirements, and it's not something that's specific to a design phase. The LOD talks about how these individual elements progress. The idea of these elements are based on the uniformat classification, so they're building assemblies. It's an exterior wall assembly. It's an interior wall assembly. It's a mechanical air supply system. It's a storm sanitary line that's in the building. It's a system. It's not specific elements. So when we talk about those elements are not set by design phase. The model element author, so we as the architect, the engineer, get to define at what specific stage in the project those model elements have evolved to the level of development that's set in the standard. And the fact that it is based on model elements, one of the big things we always talk about, and then we hear about in the US always, is there's no such thing as a LOD 200 and or 300 model. Different model elements develop at different stages. They have different use cases based on the project team, project delivery model, and a lot of different variables. So those are some of the big benchmarks that we always talk about and share with project team members as we're working to set a clear expectation. And ultimately, it's a communication tool. What we're trying to use here is setting a common ground and a common language so we don't have that misinterpretation of information that we saw with that door. We saw the dimensions, we saw the visualization things that could possibly come up and be a detriment to the project. This allows us to set the bar and have a reference that we can point to. No, this is a LOD 200 element, and this is what it means. That's all the more that you can trust it to. And we'll show how that works in our BIM execution plans and our contract language moving forward. There's a lot of different standards that are out there. Level of detail is a word that gets used in the US for the purposes of the LOD specification. It's development. And again, that development is based on the reliable output. Detail talks about the input into the document, the granularity to which something is modeled, but ultimately we're looking at how thought out is that model element and what can somebody use it for moving forward. Those are the big benchmarks that we're going for. And these are the fundamental definitions that are out there that go from 100 down to 500 that really set the basis across the board in the specification for how this information is to be used. The first one is this idea of a generic representation. And if we think about a massing model, what information do we have about the building? We can get gross square footages, cost per square foot in an early massing model like we saw in one of those first images. We can't necessarily distinguish something between a wall or a horizontal surface or a vertical surface, but we know it's there and it's implied. So it's a massing element and it's a generic representation. As we move into 200, we get into a generic system. Now we're talking about being able to recognize a door, a wall, a mechanical element, a plumbing fixture, a light fixture. And it comes with the notion that it's an approximate quantity, size, shape, and location. I know that something's here, but I'm still designing it. I'm still engineering it. I'm still figuring out how much of it there is. It's still something that's in flux. And then ultimately, when you get to 300, you move from a generic representation to specific. We're very focused on using that word specific in the LOD specification. It implies that information can be queried in the model to a level of accuracy that you have. So when you pick on that element, you dimension that plumbing fixture off the side of the wall, it should be specific to its actual location, and it's able to be trusted by a downstream user in that model. So it is specific about its quantity, size, shape, location, and orientation. And that's a big benchmark for the design professional to use. Typically, we don't see a design intent model exceed 300. Those first levels are often work that is done by the design team. Moving into 350, we have a specific system that also involves interferences. That's really the trade coordination model that we talk about, and we'll see some examples of that as we move forward. 400 talks about a fabrication level model, and 500 refers to a field verified location of those model elements throughout the completion of the construction process. And while that previous image is a lot of words, our dictionary isn't about words. Our dictionary is about graphic representations of what's there. This is a good way to really start to capture that information and talk about how we move from a estimate it, specify it, bid it, buy it, build it approach to using those different LOD benchmarks and definitions that are in place. A couple other items to know about the LOD specification is that it's a minimum requirement. Those levels of progression are cumulative. They add on to one another. You can't get to 200 or you can't get to 300 without meeting the expectations of 200. We talked about model element authors. We do not make requirements to who is responsible for, say, a light fixture. Project team defines if that's the electrical engineer, the interior designer, or the architect who is responsible for that. Those responsibilities could change throughout the project, but it's the project team's goal or responsibility to define who owns that element, at what stage, and how far it is going to be developed. It also doesn't address 2D information. This is a level of development. It's a modeling guide, so line work is not part of that component. But it does go on to further explain how we work with execution plans. Covering tolerances. The guide will not say that anything under ½ inch or 10 millimeters is not to be modeled. The project teams will define that in their language. It doesn't talk about clearances other than a mechanical system or a VAV box at LOD 300 should include the space to access that and work on that piece of equipment. It doesn't say what those benchmarks are. The project teams will start to define those. And really, again, it goes back to reliance and it goes back to not over-modeling information in the project that's there. So the next few slides actually go through a series of examples. I think this first one of a structural column really embodies the whole kind of graphic representation. At LOD 100, we know that there's some object that's holding the building up. We don't know if it's a cast-in-place concrete beam. We don't know if it's a steel beam. We have no idea what it is. There's just something there, and it's intended to be structural, and it's owned by the structural engineer. As we move to 200, we've determined a system. It's not concrete. It's steel. I don't know the specific shape that's in place, but I have identified that my structural system is going to be a wide flange shape that's holding up that is representing that column. 300, I very specifically know that it's a W10 by 48 or whatever size it is. And then as I move into 350 in our trade coordination phase, I know that it has to anchor to the building. In the US, the structural engineer wouldn't be detailing this connection location, so the fabricator would start adding that information of things that ultimately take up space. And then at LOD 400, they embark on actually having all the fabrication and installation components modeled in place that are accurate to that specific system that's there. As we go through an element or an example with a floor, we may know that at 100 we just have a generic space that's calling out a floor slab. As we move along, that structure starts to define itself as a joist that's running in a certain direction. At LOD 300, we identified as a steel joist. We know that different joist manufacturers have different webbing configurations, so we can't rely upon that information at 300. So we see that information start to come in at 350 because now it's specific about the assembly that's going in. And then 400 starts to identify all the additional components that are there. And these methodologies start to be very continuous. We look at interior walls. We go from something that's just represented as interior versus exterior, it might be skinnier or wide, to actually an accurate and specific assembly with its layers and overall dimensions. And as we go to 350, we start to see all the major structural components and kickers and other things that start to work that system together. From a supply air on the mechanical side, at 200, 100, you're really just going to have information about the system and some overall requirements. 200, now you're able to take that system and run it down from major air handlers, major trunks, shafts out through the building space. 300, you start to make all the connections from that major system down to the actual air distribution points, and then have the additional clearances. 350 starts to talk about hangers and connections, and 400 is the very specific details of how all those things come together. So you can start to see a very consistent message that applies back to those fundamental definitions that we talked about earlier. What we want to show here is the fact that, again, we go back to the idea there's no such thing as an LOD 300 model. Not everything is going to meet the same level of development based on your specific project requirement. So what we're seeing here is how those different things can start to progress through the design process. And different elements can start to come together. We might be at schematics and the walls have evolved to a certain point, but we know there's still this kind of unique amorphic curtain wall atrium space that's going in there. And it might stay 100 for quite a while. But at the end of construction documents, while the architects are building LOD 300 walls on the perimeter for those exterior conditions, we may have brought in a trade partner in a design assist capacity, and the curtain wall manufacturer is now providing an LOD 350 model components to our actual model to be part of a contribution to our final construction or tender document set. So again, reinforcing that these things do move and evolve at different paces. Last thing we want to touch on is how we actually share this information and communicate that about the project teams. Again, the LOD specification is not a requirement. It's a reference manual. It's a benchmark. In the US, what we actually see is the owner-architect and owner-contractor agreements referencing what's called the AIA's E203, which is an executive summary for digital practice documents that then references the AIA G202. And the 202 is very specifically a BIM protocol document that allows you to reference back to the execution plan or that LOD manual and starts to allow you to define these overall benchmarks. What are our model requirements? What are our standards? And then the chart over on the right allows you very specifically to go down line item by line item in accordance with the LOD specification from the BIM forum and the uniformat classifications that are out there and say at what level of development, at what project milestone will these elements evolve to. And it also allows you to put in who the model element author is at that point in that transition. So while that's a standard document, contract language is what it becomes that gets entered into your agreements. One of the things that we've done in our office at Canon Design is really have a template, a benchmark. It's a prototype. It's a starting point. Nobody takes this document as is and slips it into their contract and it fits everybody. But what it does is allows us to start to define in a traditional design, bid, build project delivery model, how have we typically seen model elements evolve over the course of the project and allow them to use this as a reference. moving forward. And one of the things you can start to see here is things come into play at different stages. Things evolve to different benchmarks. There might be examples where model element authorship transitions from one person to another. And then you also have the part to put comments in, which is a note, things that you might advance, things that might be left out, allowing you to have a very specific description of what you're delivering to your teams, what they can rely upon, and how it's used by a downstream user in the project. So a couple of the key takeaways is LOD is a language. Again, it's a reference manual. It's intended to share information and have everybody point to a single source so there's a clear understanding about that building information model as you move forward. It's not an LOD model. It's an LOD system, an element. And it's really talking about transmitting information, creating a reliability, and allowing your teams to have a higher quality model-based deliverable at the end of the day so that you can share that information and execute on your contract deliverables throughout the course of the project. And again, if you want to download that, if you just type in BIM Forum LOD spec, it'll go right to it. It's a free download, and you can check that information out and start to use that on your projects. So thank you.
It's working, this one. Okay, hello again. This is a presentation about BIM policy development with my friend and colleague, Dr. Mohammed Qasim. I'm just going to directly dive into it. There's a lot to cover, but this will branch a bit from what we discussed before. But here we are really focusing on a macro scale. Understanding BIM policy development challenges, and giving you just a taste of what it takes to develop a roadmap. Now, this is based on lots of research, and this is a quick summary. So we're going to do a tag team, myself and Muhammad. We probably exchange once or twice. Okay, it'll be tricky. We'll see. So part one, BIM policy challenges. What are the BIM policy challenges we're trying to solve? One is that decision support systems for BIM policy makers are not there, really. If a BIM policy, a policymaker wants to develop something about BIM diffusion adoption, there's nothing really to rely upon. There's no research in the field, and this is really what we try to address. Benchmarks, there's no benchmarks to assess a country against another. So how do we compare ourselves to the UK or Singapore or whatever? These benchmarks are not available, and so we had to do something about that. It's a work in progress, but it's a really interesting problem to try and solve. And the third is there's so many of these BIM documents. You've probably seen, I don't know how many, 100 BIM guides now. They resemble each other. Something's called a standard in one country, it's called a protocol in another, and etc. So we try to understand what's happening here and try to clarify what is really a protocol, what is a standard, etc. So I'm going to skip a couple of slides. So we've developed over, I don't know, maybe 2 years, a set of models that we use in assessing the performance, the macro maturity and macro adoption of countries. There's 5 of them I'm going to present today. They're quite different. Together, they help a policymaker to either develop a roadmap, just to think about a roadmap, or will help us and other researchers to look at different countries and try to compare them. So that's really what we're trying to do. Help policymakers or help researchers to investigate their own markets. So there's 5 of these models. I'm going to briefly explain these 5 and then give the mark to Muhammad. The first one, we call it the diffusion areas model. And I don't know if you remember from the previous presentation, we discussed modeling, collaboration, and integration. Remember that? Okay, now this is mapped against another 3 topics, something called technologies, something called processes, and policies. So anything we can discuss about BIM, it typically either covers a technology or covers the process of how people work together, or covers standards and protocols, or how people would like to organize work, or contracts and stuff like that. Now, to assess to have a comprehensive understanding of the maturity or diffusion of BIM within a market, we need to map these two. We have to look at modeling technologies, we look at collaboration technologies, we look at integration technologies separately. We also look at, for example, modeling processes and modeling protocols and policies, etc. So we have these 9 areas which we can focus on to assess the diffusion of BIM within a market. So I'm just quickly to another model. Now here, if we want to understand all the things that a policy maker will need to think about when they are developing a policy for their country, there's only 8 major topics to be covered. So these 8, you can see here, I don't know, maybe not clear. There's technology at number 1, objectives, stages and milestones. So whether a country or a market has clear objectives about BIM, when do they want to implement it, is it staged, etc. So we look at that. We look at the availability of champions and drivers. Champions are really volunteers. Drivers are, if you want, paid or assigned by the government. Then we look at regulatory framework, the availability of insurance policies, contracts, etc. Noteworthy publications, we'll cover that a little bit later on, but the availability of these guides and protocols and manuals. We look if there's a learning and education framework, meaning how do they teach BIM in a country, whether it's organized. We look at measurements and benchmarks. Do they measure the maturity, the capability within that market? We look at that. We look at the standardized deliverables. Do they have a standardized object library? Do they have something similar to model uses in order to standardize the deliverables and requirements? And we look, of course, at technology infrastructure. Do they have accessibility, affordability of software? Do they have a fast broadband, etc.? So we use this to look at the maturity components within a country. Now, another model, completely different. Here we look at different countries will have different dynamics of adoption. So some countries will have something called a top-down model. You've heard top-down about the UK, how they're approaching BIM. I think by April 21st this year, we can consider them to be top-down. At the moment, they're not. But once the amendment comes into force, we can consider them to be top-down. You've heard about bottom-up. We heard the example from Germany, from Ilka. It's really about when organizations adopt and over time others imitate them, and then larger organizations will follow, and then it becomes the norm, and the government or the authority will either mandate it or recommend it, or put some what's called acceptance, some kind of gateways. And the third and most important dynamic which we introduce is called the middle out. Actually, this is the most important dynamic. I mean, you know about top-down, you know about bottom-up, but the third one is important because it's missed. It's when large organizations, maybe the Defense Department, etc., adopt BIM, and because of their size, they will push it down to their supply chain, and because of their size, they will be able to influence the policies within the government and force the adoption, or at least the diffusion. So that's another model, and we can look at countries and see what kind of dynamic suits that country, or what kind of dynamic is applied in that country, and based on that, other things ensue. The fourth model, here we are looking at what the policy actions taken by the policymaker. Some countries prefer a passive approach by the policymaker, so the policymaker does not do anything, really. They just make aware people about BIM, maybe just encourage them to move in a certain direction, or it could be more active. They really spend money into education, into incentives, or it could be more prescriptive, assertive, where they say you have to adopt BIM, and this is what we mean by BIM, and these are the standards that you need to follow, etc. So these 3 approaches matched by activities, you'll get 9 actions, and we can measure these and understand the difference between countries. And the last, but not least, model is really who is responsible for BIM diffusion, and who should we work with, and who should do what. We identified 9 players, if you want, which are different from the individual to the educational sector, to the association, architects association or engineers association, to building smart, like a technology advocate, or the communities of practice, user groups. You've got 9 of these. 8 of them, except the individual, we remove it. We can map them against the 8 components, say whose responsibility to develop this, or who is doing that. So we can use it both for measurement and for planning. These are the 5 models, and I'm going to stop here and give one more.
And in this section, I'll explain the result we obtained from benchmarking about 20 countries using the 5 model we Bilal just explained. Basically, we contacted about 95, more than 100 experts. We got the answer from 95 experts. And this is the country, sample country we are covering in the presentation. They include from all regions: South America, North America, Europe, Southeastern Asia. And I'll show the result model by model. If I start with the first one basically is measuring the diffusion areas, the 9 diffusion area Bilal explained. By the way, I'm not showing all countries here, 20 countries here. I'm showing just a sample because to make it more clearly visually. So in this, for example, here you could see quickly that different countries they have different level of diffusion, but there is a trend among all countries where modeling and its capability stages, its fields, basically modeling is the most highly rated in most countries. And this is a trend among all countries. And this is logical, given all the presentation we have seen, like level 2, level 3, and modeling, collaboration, integrations, are all subsequent levels. If I move to model 2, model 2 basically is measuring those 8 area of macro maturity, 8 areas that should be in any country within a national initiative, for example. You can see, for example, there is a clear lead here for the UK, which scored like higher, much higher than, not much higher, higher, relatively high, a little bit higher than other countries in all the 8 areas. And for example, Spain, you could see as well, all 8 components are present. However, the maturity is still low and low medium across all the 8 components. If I move to model 3, the same model, but I just take one of the components, and in this case, I'm taking the objective milestone and stages. You can clearly see that in most countries, really, they all fall below 1. Below 1 means they all stand at low maturity. The only 2 countries which are above 2 are the UK and China, and that means the objective and milestones in those countries are well defined and well managed centrally. Okay. If I move to the third model actually is about the dynamics, the diffusion dynamics. And it's very interesting to see that most countries, 65% of countries we investigated, they have the dynamic which is middle out, where large players, they diffuse BIM down to the supply chain and upward to the policy. Only 2 countries are top down in this scheme. It's in this study are Hong Kong, the UK, and Emirates. Moving on to the next model. The next model basically is mapping the policy action across countries. And again, here you find 65% of countries, the policy maker approach to BIM is fully passive in terms of communication, engagement, and monitoring. In the Netherlands, we have slightly different approach where it has 2 active elements, which are basically the policymaker are educating, incentivizing the industry to adopt BIM. In 5 countries, we found another pattern. Basically, in 20% of the country, which are 5, we found an approach where it's about educating, encouraging, and observing. So it's again mixing some element of active approach with some element of passive approach. Finally, we have the UK, which is different from all other countries. We have a mixture of passive and mostly active and assertive, where we have education, enforcement, and tracking. So those are the different patterns. Moving on to the model showing the role, the contribution of the different player groups in different countries, you can see like different countries really, they have different level of contribution from the player groups. Some countries are more balanced, like the Netherlands. All 8 player group are contributing to pushing the BIM strategy of that country. Other countries, for example, you can see like the New Zealand, the policymaker role is very, very tiny, almost absent. The final model is basically instead of just measuring, rating the policy, the group player contribution, we could really more qualitatively rate it as like leading, supporting, and participating. And this is a slightly better representation than the previous one. It could be used in planning responsibilities within a national BIM strategy. Now, the section, would you like Bilal to move here? In this section, basically, there is a problem. Like, for example, Brian just explained the LOD. Some people would call LOD as standard. LOD are not standard. LOD are specification. So, and this problem goes over and over again to all type of documents. Protocols they are called, guides are called protocols. Standard are called specification. It's all mixed, really. Not only really in translation, also in English-speaking countries, we have this problem. So what we did, we developed a taxonomy where we specify what is a guide, what is a protocol, and what's a mandate, and what should be included in each of the document types. And we realized that International Building Smart, they have a similar project, and we are now exchanging experience in this area. And what we did, after developing this taxonomy, we mapped about 60 documents from 8 countries across that taxonomy, and we find really there are some countries they are covering like the guide, mandates, and protocols. Some countries are mostly like they have no mandate at all, like the Australia in terms of their BIM documents. Moving on, the same documents, we could really develop a specific metric to measure their relevance. We could measure them across like this metric from R0 to R4, from redundant, relevant, regarded, recommended, required. And this metric could be really important to prioritize or like filter those highly regarded BIM document from those like which contain information that's already outdated. Finally, based really on this research, I'll explain quickly how you could use those models to develop a process map. Based on this research, one day we got a call from the Brazilian government, said, we have seen your work is very interesting, we want you to develop a policy roadmap for Brazil. And he asked us really to look at 5 countries. He said, look at these 5 countries in EU, analyze them retrospectively, and tell me what should I do for my country. And at that time, we didn't have the metrics to measure each of the 8 areas. Each of the 8 components. So we used a simple traffic light system that goes from something not started, something just started, something under development, and something well developed. And we did this for all 8 areas. So you have on the left side, you have all 8 components, and on top you have countries. And you could follow this map easily. You could look, for example, at a country where there is a red light. That red light, for example, in the case of Finland, I could look horizontally and look where there is a purple light, and I could go and learn from that country. And we did this. At the end of this, we developed with the participation of all stakeholders, all of them in Brazil, we developed a policy roadmap for the country, which is, you can access it, it's available publicly, which cover all the 8 areas in terms of roles and responsibility, what to do, how to develop a mandate, what the mandate should look like. It's available in public domain. You could have a look at it if you are interested in knowing more about it. Would you like to do this, Bilal? Thank you very much. I'll leave you with the last 2 slides with Bilal. Thank you.
Thank you, Rahman. Okay. No? Okay, just quickly, there's only 1 minute and 34 seconds and 27%, whatever. So BIM policy development, just a quick and generic. So we're just going to use one model. Remember, all these models are generic. They're not mapped to time, for example. There's no milestones or whatever, and they are independent. We can, of course, combine them all in a framework, but we're going to give you just a couple of examples. So we'll take this, what we call Model B, or the macro maturity components. There are 8 in it. They are interconnected. Even these small components are interconnected. We can measure them independently, but also we can measure them as an interconnected mesh. One way at looking at them is that just put them in a matrix, for example, and we've got these 8 you can put against the milestones, let's say 2017, 18, etc. It doesn't really matter. You can put whatever milestones you like. And then you can, for each of these milestones, you can say, what is the maturity for that specific component at that specific time? This is just a template that a policymaker can use. You can change the text inside to suit their culture, to their macro maturity, macro adoption dynamic, because each country is different, and even within the same country, there are different dynamics for different regions. So that's it for us. We still have 21 seconds.
Thank you very much.
All right.
Yeah, it's just gone. 0. Yeah. Okay. Yeah, I'm still on 0. I wonder how much time I've got. Okay, in terms of what I'm going to talk about today, I'm going to talk about the digital praxis of BIM and discovering the question that has never been asked. Just to give you a bit of background, I'm David Morton. I teach architecture at Northumbria University. I also practice as an architect in the UK. Scarily, somebody asked me today, how long have you been an architect? And I said, actually, I've been 23 years, which is a bit scary. Time marches on. In terms of my side of things, in terms of teaching, I've been at Northumbria University now for 7 years. And in terms of the number of students I've actually taught, it's about 2,500 future architects, which again is quite a figure. We've talked about various figures today in terms of impact. And somebody did say to me, how many students have you actually taught over your 7.5 or so years? Before I joined Northumbria, I worked for a small company you might know called IKEA. I was their lead architect, designing and developing affordable housing, or flat pack housing. I do feel quite guilty that I've given the world of architecture the term flat pack houses or flat pack design. I do apologise for that. In terms of what I'm going to talk about today, it's about looking at design, looking at the way in which we use BIM, and in a way, it's quite cathartic for me. It's like four years of research I'm going to try and cram into 15 minutes, which is going to take some doing. And Brian said he is going to hold up a sign in a little while. It's about 10 minutes to tell me to breathe. In terms of the work at Northumbria, I'm part of, when I started working for Northumbria, because they asked me to be part of the BIM Academy. I'm very proud to be part of the BIM Academy. I'm also part of the BIM Academy in Spain. And in terms of what we do there, we make sure that the future architects that we teach understand how to use digital methods or digital praxis in their exploration of how they design. And that's really important. Today we've seen loads of examples of big pictures and pretty pictures and diagrams and all sorts of things. That's really important when you're working out how to design things in terms of how you graphically represent those things. And two things I want to talk about today, or two terms, are abstraction and simulation. Now, abstraction, I'm now coming up to 47 years old as an architect, and I started off doing abstraction or using abstraction. I used to draw all the time. The pen on paper, it's a beautiful thing, I keep telling my students. But my students often use simulation, and that's what most of us have been talking about today in terms of BIM. So what I'm going to do today, hopefully in around about 9 minutes and 15 seconds, is go through everything from introduction right through to findings and the digital fourth wall, and hopefully keep the time. So in terms of where we are now, I'm now teaching students who previously wanted to push the analog way of experimenting or searching through their designs, moving towards more digital methods of abstraction and simulation in terms of how they learn and how they use these methods to understand their design at a far richer and deeper level in terms of every last bit of information, every last bit of detail, how to use materials, where to use them, how to use them, structure, spatially, the whole thing as architecture with a capital A. I've always been asked, especially my children when I come back from work, what have you done today, Daddy? Because I always say, what have you done at school today? So I say, any of you are architects, if anybody asks you this question, you come home from work, you've actually done 92 things. Okay? These are the taxonomies that go through the design sequence from incubation, concept thesis, design development, detailed design to final communication. We do naturally 92 steps or 92 stages. In terms of the 4 years that I've been looking at the way in which digital praxis influences the way we design, I've looked at it under 4 banners or headings, if you like. Exploring the dichotomy, looking at immersion and synthesizing designs, the conjectures and refutations in terms of sequencing and how you look at the design, and then how to design without prior concept of knowledge. Now, in terms of research, it's an amazing thing. We've talked today about the implementation of BIM, the way in which BIM has changed the way in which we design, the way it's impacted on architecture and construction. In terms of the various research that Bilal and Mohammed and myself do a lot of, if you look at digital methods or digital praxis in terms of research, we started off in the 1960s to 70s with just 13 papers on digital methods of design compared to 6,600 papers on architecture design itself. So only 0.2%. We've moved right the way through to 2010, 2015. Now it's a fantastic 5,500 papers, but in terms of a percentage, it's still fairly low. So we talk about the impact of digital praxis, of BIM and so forth, but in terms of papers and research, I think we've got a lot more ground to cover. The same thing can be said in terms of the various papers. You go back in terms of theory from Popper to Brunner, Eastman, Piaget, Schon, Cross, all of these people. And every single one of these, up to around about the 1990s and so forth, was 53 years worth, was looking at design pre-BIM. It's only in the last 10 years where digital practice and BIM has really started to become part of educational theory. Back in 1953 was the very first curriculum set out in the UK, and it's took all this time for us to kind of look at how we design and how we influence the way in which we kind of look at design within universities and within, as architects. Back in 1953, you had the idea of pencil on paper, that beautiful thing I keep telling my students. As architects, we have this fantastic ability to sit in front of a blank piece of paper with a pen, and as you strike the pen across the paper, as you lift it off, you've created something. And that's a fantastic thing to do as a job, as an architect. Back in 71, you had the good old days of pen and ink. I remember shaking these pens when I was a student to try and get a little bit more ink out of them. And then you had, in the 1980s, the dawn of CAD. And everybody thought that the drawings were dead, that CAD was the new revelation or revolution. And now we have the kind of 20s, the 2000s to 2012. It's starting to move towards post-CAD and post-BIM in some respects. What I've actually done is look at how this has impacted in the way in which we teach, the way in which we teach design, the way in which our students learn, because they're the generations that are going to be the ones that carry on, that hold the baton and carry it on. So to do this, I got 12 of my students as a pilot study to design or model the Domino House by Korb. And these are the 12 students. Every one of them was coded, and every one of them was asked to draw, and then model, and then BIM the Domino House. Every one of those sequences was coded as well. In terms of the pilot study, you had to look at an analog study of the sketch, which was task A. Task B was then the pilot study in terms of the analog making the model, so using the motor skills. And then the third one was looking at the digital study, using digital praxis or digital methods, BIM and other methods. All of those were codified. And in terms of results, I'll go into those in a second. But in terms of results, there were some really interesting findings. So how did I do this? How did I watch what they did? Well, from 1953 until Donald Schon, Dewey, Brunner, and all the theorists to do with architectural pedagogy, they only saw it from a second-hand point of view. They observed. What I wanted to do was get inside the head of my students to understand how they ticked, how they worked, and how BIM and digital methods and digital praxis was affecting or helping them or assisting them in the way they explored their designs. So what I was very lucky to be given was some money towards buying some equipment, and that was a set of eye-tracking glasses, the Tobii 2 Pro glasses, and that allowed me to look at post-analysis of the visualization. It allows me to have all of what the students see on the laptop. It allowed me to map the aggregate, the data in terms of where the students were looking, the eye tracking, the gazing, and the way what they looked at in terms of heat model, so where they looked at, how long they looked at it. And then in terms of looking at the software, I used the Glasses Analyzer software, which came as part of the kit. And that allowed me to look at all of the stats and all of the information, the gaze plots, and how long they looked at various viewing patterns. I'll just watching the time. Okay, I'll get to that. Now, on top of that, I asked the students to wear an EEG headset. This allowed me to map not only the gaze data or the visual data, but looking at it in terms of what fired off in terms of the brain activity. And there are well-known areas of the brain, which are AF3 there, F3, FC5, and so forth. They're well-known positions within around the brain that they fire off at certain points when you do certain functions or certain activities. So I linked that with the general interpretation areas, the motor association areas, that's when they were modeling, when they were doing the 3D sketches, and also the sensory association areas. And then map this along with the various categories that you get within the headset to do with engagement, excitement, irritation, because we sometimes get a bit annoyed about the third iteration of something we do, anger or calm, and hopefully not boredom. So, I didn't actually get any triggers for boredom, so I hope I'm doing the right thing in my lectures. In terms of the graphic I've used before was the light bulb. I think it's about time in architectural education we smash that light bulb and look at things in a different way. Previously, the idea of initial ideas going through analysing in terms of synthesis and evaluation, when you push it through in terms of digital abstraction, we start to get far richer parallel abstractions of ideas. And if you look at it in terms of the various paths from a timeline for a learning journey, again, I mapped that and looked at the way in which BIM, augmented reality, and all the various other elements of digital praxis also affect the way in which our students learn and search through their design basis in terms of their various projects they do. And very simply, in terms of the analog to digital move within architectural pedagogy, the idea that you have the analog cycle of generation to performance simulation to evaluation, it's now changed. It's now performance simulation first, trying the what-ifs, if you like, and then generation and then evaluation. In terms of outputs, because the students are far more digital natives than I ever will be, they are now Generation Z, I'm Generation X. They were looking at using the PCs, laptops, iPads, and so forth. And in terms of their iteration loops, they were far finer, far richer. And that's the original iteration loop of analysis, synthesis, and evaluation, but going through the problem and solution spaces that are well known in various architectural theories of ideation. In terms of the way in which they studied, 70% of their activity was looking at the way in which they explored spaces. Why? Because they could model things very quickly, try it, look at it, and try and understand what effects their design changes were making in terms of the final architectural project. And in terms of the various stages, the idea of what I talked about right at the start, initial design exploration, the abstraction of the idea, and when you reflect and think about and cogitate about what you've just designed, and then you synthesize at the end. If you look at the various percentages, they're fairly equal. So there is no push anymore. There is no kind of spike when you use digital abstraction in terms of architectural pedagogy. The various different types of software were quite mixed. Everything from still, the pen on paper was still used, but only 21% of the time. 76% and 65% were the highest, and that was looking at Autodesk or Revit or SketchUp or so forth, the visualization methods. In terms of the outputs, what you see at the end of on a degree show at any architectural school are the pretty pictures, are the visualizations. But what's really important for the next generation of architects is to understand how they actually got there, what the buildings do, how they work, how they function. So in terms of the research thus far using the headsets, I've started to look at a way in which the students learn and what iteration loops they go through. And I've called this the cradle principle. This is the initial loop, where you then have a series of solution spaces that they go through. This is all because they use the kind of fast, iterative digital methods of exploring their designs. So they go through between analysis, abstraction, and then back to analysis, and back to solution space. And then they do this again and again at infinitum. Why? Because they can, because it speeds up their exploration process. Right at the very start, I talked about the way in which I'm trying to get inside the students' heads. And I kind of liken this to the idea of the fourth wall you may have heard of in terms of on the stage. The idea that you as the audience can peer into this virtual world. And the fourth wall is where you are in front of this stage, and I'm standing on the stage with the other three walls behind me. That fourth wall allows us as the audience to peer in and view that world and make our own mind up of what it's about, our own perceptions, perceive what we want to see, understand it, resolve it in terms of how we see it, and then take what we want individually away from that particular occurrence, that performance or whatever else. And I think in terms of digital practice and using BIM and methods like that, we are now seeing this idea of peering into the fourth wall within digital practice. The idea that our students see the idea of, or feel the idea of having this talk back. And that's something that's been talked about right at the start of architectural theory when we talked about hand drawings, the idea of drawings talking back. That's happening at a far quicker level, and the dialogue of talk back is becoming far richer in the design thinking realm. And finally, and secondly, in terms of the way in which we teach our next generation of designers and architects and others within the construction industry, we're starting to see the idea of having a new generation of students using these digital tools or becoming digital tool makers. They're becoming the new, what is termed the digerati or the digital literati. They're the idea that there's a new idea that the taxonomy within architectural pedagogy is needing to be changed. Like I said to you, the last 10 years, impact of BIM has happened quite strongly. Before then, there was a massive resistance. There was a resistance for CAD when it first came out in the 70s and 80s. People thought that if you lost sketching and you went into the realm of CAD, that would be a bad thing. It's now the norm. The same thing is happening with BIM. It was pushed away, now it's being accepted. We've seen a far richer environment in terms of pedagogy and learning. Thank you very much. Thank you.
Bien, buenas tardes a todos.
Well, good afternoon, everyone. I'm sorry that I cannot do my presentation in English, but I'm happy because we have a really good team of interpreters helping us. Well, good afternoon. My name is Javier Chavez Carrascosa. I'm a technical architect and also graduated in edification techniques. I work as an architect technical, but I also am the head of certification for the ACP in Barcelona. First of all, before I start with my presentation, from ACP I want to thank the organizers of this event for having invited us to the second European BIM Summit. I would also like to say we are really glad to be able to show you for the first time, and also the people following us via streaming, about this first professional certification as BIM manager that is based in the international standard ISO 17024. I want to talk about the reasons why in our professional certification catalog we are including this BIM manager specialty. As we've heard already in the interesting presentations we've had today, the implementation of this new methodology, this new collaborative working methodology, leads to new roles, new professional roles, and we have the BIM manager. I liked Ilka's May presentation because we saw that we need to decide what we understand under the concept of BIM manager. How are we going to define the BIM manager concept? So as you see in this slide, we see it's a role that has a large demand in the current market. There's really not much regulation regarding the roles and competencies that this role has, and we also see that there are multiple courses and postgraduate courses, even master degrees. We have also seen that many of the professionals who work in this area call themselves BIM managers. Therefore, we thought that it was necessary to regulate this specialty. A large volume of data has emerged, and also BIM procedures. Also, this technology is multidisciplinary, and these three things affect the stakeholders who participate in the life cycle of a building. Therefore, the BIM manager role will be in charge of monitoring, controlling, and coordinating the BIM model. The BIM manager has to be a facilitator of the technological environment for the different stakeholders that take part in it, and to do so, he must propose and coordinate the definition, implementation, and compliance of the BEP, the BIM execution plan, as we have mentioned in other presentations today. But we have a question here. If there's no regulation whatsoever regarding the roles and competencies of the BIM manager, from this ACP agency, what we are doing using the ISO 17024 is creating a committee for the scheme. This committee will have all the stakeholders represented, all the stakeholders that are interested in the BIM manager certification. As you can see in the slide, in the committee we have experts of the area, we have public administrations, we have private companies, business associations, the academia, headhunters, the technological sector. We have all these stakeholders that have something to do about this professional profile. I'm also proud to see that I'm seeing many of those profiles in this event. There are almost 30 experts in this committee, and last December 10, 2015, they approved the functions and competencies as well as requirements that will be asked to a BIM manager. But once we have this guide from last December, how are we going to have a professional being certified as a BIM manager? Well, our system is based in a cloud online platform. You can access to it through our website. Once you have signed up, the person will have to send his application. He'll go through an assessment process where we will check the requirements. This person will have to pass an exam in some categories and also an interview. Once the person has passed the interview and the exam, the committee will make a decision, and if it's deemed appropriate, the Commission will grant the certification. As you see in this slide, the certification must be renewed at some point. When we give the certification to a person, we want to have his training. We want him to have an ongoing training. For the BIM manager certification, the validity will be 4 years. Afterwards, the person will have to renew it. What do we take into account when we assess a candidate? Well, regarding the assessment of all documentation, the person will have to justify some generic training in architecture and building, university training we are talking about, and we will also demand some specific training. Also, once we know that the training is appropriate, we are going to ask for another requirement. We are going to ask for professional experience. If you look at the slide, you'll see that we have different categories. For example, in this specialty, this BIM manager, we see 4 levels. We go from the professional certification through the advanced and expert certification. So the BIM manager will grow as the experience grows as well. The person will also have to send some proof of the works that this person has done. And in order to test the competencies, he will have to pass an exam. On the lowest side of the slide, you see that also part of the assessment will include the values and also a code of ethics that will have to be accepted, the ACP code of ethics. Well, as I said, our certification is a pioneer. It's based on the ISO 17024 norm. And what we want to do is to grant certifications through the ENAC, that's the Spanish certifying body. And by having this certification, what we are going to do is that the ACP will act in an independent way, with transparency and with no conflict of interests. Therefore, because we have the ISO 17024 supporting us, what we want is to have also the support of other countries. And after passing the certification process, what's going on for the candidate? Well, first of all, we like to say that it's a voluntary process. And it is true that the professional certification is a way to prove the professional value. So by having this BIM manager certification, the person will have a certification that will make a difference in front of the customer and when applying for a job. It will also foster the personal image of the person and the professional image of the person. And this person will be able to use the distinctive you see on the slide that shows that this person has this certification, what category has this person achieved, and also the number of certification. And this person will be able to use this number in the visit cards, in when applying for a job, and so on, as I said. And also, if this person also gives authorization, the name of this person will be included in a list that will be open to the public to check. So we invite you to sign up in our website so that you receive all the news. And we also invite you to follow us on our social media, LinkedIn, Twitter, and so on. If you have any doubt or you would like to ask me anything, we will be available at our Madrid and Barcelona offices, and you also have this website, agenciacertificacionprofesional.org, as you see on the slide. And finally, I want to thank you for being here, and I want to thank you your attention. And we hope that you consider us an option to give new value to your curriculum and your personal brand. Thank you.